Hi everyone, welcome back to my channel Vertex MrRoy. Exercise 9.3 question number 2. Before starting this question number 2, I would like to request to everyone, so please watch first video of 9.3 so that you can understand what is inverse function and how we draw the sketch of inverse function. Okay, so let's start. A 1 function, okay, is 1 function. Please remember, for the inverse function we always need 1-to-1 function. So f of x is x square minus 2x, and normally when I have quadratic equation I always convert into complete square form like this. X minus half of 1 is 2 is 1 whole square and minus 1 square, and then it's coming only this. So turning point is coming 1 and minus 1. How we can get this done like complete square form, you should watch chapter number 4 video. This already I have cleared this, written the heading, this complete square form, so you have to understand. Otherwise we can draw the sketch, but this is my method. I always need a turning point to draw a sketch, and when I substitute 1, because of 1 and 3 the domain is given, so I will substitute 1 now. When I substitute 1, the value is coming 1 square minus 2 times 1. So f of 1 is coming 1 square is 1 minus is minus 1. So the coordinates are 1 comma minus 1. It means it's the same as a turning point. So that's good. We can have the same thing because the graph of, like, when I draw the graph of quadratic function, and when I from the turning point when I move like this, inverse is not possible. For inverse, the graph should be till here. This is 1-to-1 function, because 1-to-1 means this is 1-to-1 when I draw horizontal line. But when I move, like when this is the graph, when there are 2 points with the horizontal line, the inverse is not possible. Inverse, like for example, when I have this line, inverse is possible because when I draw horizontal line, there is only 1 point of intersection. When we have quadratic curve, now 2 point of intersection, inverse is not possible. So this is very important. For example, if I have this thing like this, and when I draw horizontal line, there is cutting at 1 point, means inverse is possible. So okay, so now I will substitute 3. When I substitute 3, is coming 3 square minus 2 times 3, and 3 square is 9 minus 6 is coming 3. So the coordinates are 3 comma 3. I have explained in exercise 9.1 video this how which diagram or which functions are can be changed into inverse function. I have explained in detail. Okay, I want to draw the graph, like sketch, sorry. The sketch means we do not need to plot all the points. No, whatever you need. I always use the turning point, and the turning point is same as this coordinate, so it means that's good. This is 1, this is 2, this is minus 1, this is minus 2, and maximum is 3. So we can make till 3, and 1, 2, and 3. Remember, when you draw the sketch of inverse function, the scale should be same, like this distance and this distance, x-axis or y-axis should be exactly same, otherwise it's not possible to draw the inverse function sketch. So 1 minus 1, 1 minus 1 is this coordinate, and this is my method. Whenever you have this situation, always draw at a turning point, always draw symmetry, line of symmetry. And second is 3, 3. The 3, 3 is coming here, and that's it. And we don't need to do anything, just very simple to draw the sketch, and that's it. And if you want to get the this coordinate, where should I intersect with x-axis, you can do one thing. It's optional. You can do one thing, that here the x is 0, so I can write, sorry, not here, I will find fx, so I will write 0 square minus 2 times 0. So when x is, sorry, y is 0, so y is 0 means I will write 0 is equals to x square minus 2x. This means on x-axis the y is 0. So when we simplify this is only optional. X is coming 0 and x is coming 2. So it means this coordinate is 2 comma 0, this is 0 comma 0. So it means when I draw the sketch, the curve will intersect with this point, And when I make a complete sketch, it will again move from this point 0, 0. This is a complete sketch of the quadratic like here. But when the domain is from 0, 1 to 3, so I will not use this. And this is enough. This is the exact curve because the domain is from 1 till 3 and we have drawn the sketch first. From the domain, like from the sketch, we can also find the domain when we need. Do we need to find? Okay, sketch the curve and say the range of f. Okay, range means I need the minimum value of y and the maximum value of y. What is the minimum value and maximum value? Check it out. The minimum value is here is -1 and the maximum is 1, 2, 3 is 3. So the range of this question will be not equal to because equal to is not here. So range is from -1 till 3. And this is the range of the first part. We have done it. Now moving to part B. This we have done it. Okay. Sketch the graph of f inverse. Okay, this is f inverse means I need a horizontal line. I told you in the last video. For the horizontal line, we have to draw like this, y is equal to x. And y is equal to x should also extend in backside, like this is y is equal to x line. And when y is equal to x is given, I have to reflect this curve, this f of x, and y is equal to x. So when I reflect that this is 3 comma 3. That's why it's coming. On this line, this is 1 1 2 2 3 3 4 4 5 5 6 is on. So now drawing the sketch. So what we need the same point is here. This 2 0 will become 0 2 here. I will write this coordinate here 0 2. And the third coordinates here is 1 minus 1 1 minus 1 will become -1 and 1. This is normally reversed. 1 and -1 and 1 is here. So okay, these are the coordinates. So we can draw this is sketch. Oh, sometimes this is f inverse x and we have done. It's very simple. Now they asked to write the domain, state the domain of f inverse. So for the domain, what we need? We need the value of x. So value of x means this is the domain, like the graph is drawn till here. So this is the domain for this inverse. So what is the minimum value? The minimum value is this is -1. So domain for the second part is -1 till this is 3. And this is called the domain of this question number like 2 part B. Moving to question number 3. In question number 3, find the f inverse. Okay, so f inverse I already explained in 9.1 video, sorry 9.3 part 1 video, how we find the inverse. Inverse method is very simple. Step number one is you always like write fx equals to y. So fx equals to y means this will become y is equals to 3x minus 2. Step number 2 is we make x subject, make x as a subject. So when you make x as a subject, so what you do, we do like this, y minus 2 will become plus 2 is equal to 3x and 3 will divide, so I'll write x is equals to y plus 2 divided by 3. Now step number 3 is what we need to replace x with f inverse and y with x. So the final equation will become this will become this equation, this will become f inverse. So f inverse is equals to this y will become x plus 2 upon 3 and we have done it. Okay, now part B I will be doing in direct, like not in detail. So f of x is equals to 3 upon x minus 1. It is not easy to make the inverse function of the quadratic equation. I have like 3 methods to make the inverse function. Let's see. This is very simple. I write y is equals to 3 upon x minus 1. Then we do the cross multiplication, so it will become we have two methods here. So xy minus y is equal to 3 first. Then you can write xy is equals to 3 plus y, and x is equals to 3 plus y upon y. Now step 2 done. Step number 3 is what we replace. So this will become f inverse, and y will become x, but in both the positions. So this is like inverse of part B. Moving to part C now. F of x should be equals to y. So I'm doing directly now. Y is equals to 2x x minus 2, where x is 2 times. There is no problem. When you have x 2 times to make a subject, always keep x in left hand side. Okay, let's see. Xy minus 2y is equals to 2x. In this situation, you have to keep all the x in left hand side. So xy, this will become minus 2xy, and this we can shift in right hand side, 2y. Now, when this x is coming in left hand side, we can take x common. Y minus 2 is equals to 2y, and x is equals to 2y upon y minus 2. And now step number 3 is what replace. This will become f inverse, and this all values of y will become x, and we have done. In part D, what we do, y is equals to, we have y is equals to, again 2, x is 2 times here. There is no problem. You can do one thing, this you can uh, make x as a subject, so make all the x should be in left hand side. So 2xy minus y is equals to 2x plus 3. I multiply this here, and 2xy, and this x, so like 2x should be here, 3 plus y, this y shifted in right hand side, x is common, so 2y minus 2 is equal to 3 plus y. I can make x as the subject. It's very simple now, and is coming 2y minus 2. Now replace, this will become f inverse, and this we write x upon 3x minus 2. So by this way we have done question number 3. For question number 4, once again we need to make the inverse function of this f of x. And inverse making, we have 3 steps to make the inverse function. So because we need here f inverse minus 1 and f inverse like 1. So it means we have to find the equation of f inverse first. So this is y is equals to 4x minus 9 upon x minus 2. When x is 2 times, we always make like keep x in left hand side. So when we multiply with y, it's coming xy minus 2y is equals to 4x minus 9. Keep x in left hand side, xy minus 4x. This should be in right hand side. So this 2y minus 9. X is common. We always take x common to make the subject. X minus, sorry, this is here 2y, or this is 4. Okay, this is 4x actually. So this is 4 left. So 2y minus 9. And when you make x as the subject, it's coming 2y minus 9 divided by y minus 4. So the f inverse will be equals to this y will become x. Now, this is the final equation of the inverse. Now, what we need to find the a part, the f inverse of minus 1. When I substitute minus 1 here in this equation, so 2 times minus 1 minus 9, and minus 1 and minus 4. So finally, it will be minus 2 and minus 9 is minus 11 and minus 5. So it's coming 11 upon 5. So this is f of minus 1. We need to find f of 1, f inverse of minus 1. We need, second is f inverse of 1. F inverse of 1 means I have to substitute like only the 1 in the place of x, and 1 minus 4. So it's coming is minus 7 upon minus 3. So finally the f inverse of 1 is coming 7 upon 3. So two values are there. Second part B is given here. Find the value of x for which the f of for f inverse x is equals to x. This part we need to put the whole equation of f inverse is here 2x minus 9 divided by x minus 4 is equals to x, and just we need to simplify now. So when 4 is multiplied with this is coming 8x minus 36 is equals to this x minus 4 multiplied on right hand side x squared minus 4x. We have a quadratic equation. I move all in right hand side x squared minus 4x minus 8x and plus 36. Let's check what are the factors. 8 is coming 12x minus plus 36 because we have to make the factors x squared minus 6x minus 6x plus 36 equal to 0 because the factors are multiply to get 36 and plus to get 12, so 6 and 6 are the factors, or even you can use the quadratic perfect square formula. X is common in first two, x minus 6 minus 6 is common, x minus 6 equal to 0, x minus 6, x minus 6. So we have the same answer, so x is coming only 6, and we have done it. Question number 4. Question number 5 is a function is 2x plus 2 x minus 1, where x is not equal to 1 means this cannot be 0, because when I put 1 here, 1 minus 1 is 0. It shouldn't, denominator should not be 0 for a function. The first part is to find the f inverse. So f inverse means I have to write y is equals to 2x plus 2 divided by x minus 1. And second step number 2 is make x the subject. So x is 2 times. When I multiply this, is coming x y minus y is equals to 2x plus 2. 2x in left hand side when we shift is coming minus 2x. Y in right hand side is coming y plus 2. X is common. So y minus 2 is there, then y plus 2. So when you want to make x to the subject, this y minus 2 will divide. This is a complicated case when we have x 2 times to take common, so be careful. Now, step number 3 is what? I have to write here f inverse x, and the y will become x plus 2 and x minus 2. This is the equation for the inverse. And as we want to find f inverse 3, so I write f inverse 3 is equals to, I will put the value 3 plus 2 divided by 3 minus 2, and 5 upon 1 is 5. So f inverse of 3 is equals to 5. We have done the first part. Part B is f inverse of p is equals to kp. So it means I will, in the place of x, I will write p plus 2 divided by p minus 2 is equals to kp. And what they asked, right, express k in terms of p. So, okay, we have to make k as a subject. So p plus 2 is equals to kp times 2 is kp squared, and then minus 2 kp. And we want to make express k in terms of k. We actually, it was very simple to make here, I think. So we can divide this p in left hand side. It's easy, I think so. Because we are making express k in terms of p means this p will divide here and this will become here. So this will be k is equals to p plus 2 divided by p squared minus 2p. And there is no, okay, that's good. And we have done it. Question number 6. Of x is equal to 6x minus 2 upon x. This question is one of the important questions because we have the quadratic equation here. Let's see. So we need f inverse minus 1. So y is equals to 6x minus 2 upon x. When you take the LCM, is coming only x, and this is 6x squared minus 2. When we move from right hand left hand side is coming yx
is equals to 6x squared minus 2. If I want to make x squared positive and this in right hand side, so it's coming minus. I'm writing yx, not xy. That's the reason actually I will tell you now. Uh, in quadratic equation, when I take x common, here x squared, here is x. I cannot take x common here. This is not possible. For this situation, remember the quadratic formula is x is equals to minus b plus minus under root b squared minus 4ac divided by 2a. So this formula will be used to make the inverse function in quadratic equation. In quadratic function, we always require the quadratic formula. So a is 6, b is minus y, and c is minus 2. Just put the value because when you see this quadratic formula, there is no x in right hand side, so x is already a subject, and our target is to make x as a subject. So x is equals to minus b is minus, and this minus will become plus. So this is coming, let's see, is minus y plus minus under root this minus y squared minus 4, a is 6 and c is minus 2 divided by 2a is 6. We should like this is a square is I think so everything is good. X is equals to plus y and plus minus y squared minus 4 times 6 is 20, 4 times 2 is 48 is plus 48 divided by 12. So now, when we make f inverse, this y will become x. And this is x squared plus 48 divided by 12. Now we need to find f inverse minus 1. So when you find f inverse minus 1, this will become minus 1 plus minus minus 1 squared is plus and 48 plus 40 like 40 plus 1 is 49. So it's coming 49 means I have to write here f inverse of minus 1 is equal to minus 1 plus minus 7 divided by 12. I will write one time like minus 1 minus 7 upon 12 and minus 1 plus 7 upon 12. So this is minus 8 upon 12 and minus 3 upon, no, 8 upon 12 means 4 upon, let me write it, 4 times like 2 and 3, okay, 2 upon 3, negative 2 upon 3, and this answer is coming 6 upon 12 means 1 upon 2. I will use only 1 upon 2 because negative here already given in the question, x is greater than 0 means, please, x greater than 0 means x is positive. This is the shortest way to write x greater than 0 means x is positive, so I will ignore this value. And the right answer is like 1 upon 2, x equals to, this answer is coming 1 upon 2. Next part is B part, and I think this is very simple. There is no problem to do it. Moving to the next part for what value of x when f(x) equals to 1. This is also simple. I don't want to do it actually, but I can explain you that this part, this f of x, I will write 1 is equals to 6x minus 2 upon x, and when we can have like this is a quadratic form and we can have two answers of this. So by this way we have done till question number 6 today.